Yeah, thanks, guys. Yeah, so feeling better. So thought of taking class today. All right. So I have covered few of the topics already from the network assurance. We have done span, R span, ER span, ping, trace route, and also conditional debug. So for the day, I have two topics, both related to traffic inspection. One being called as IP SLA or IP Service Level Agreement, and the second one is Cisco NetFlow. So both are easy topic. We'll go one after one. Okay, so first I'll cover IP SLA. We will have some lab, and then we will move on to the next topic. Okay, so this is IP SLA. So this is a feature which is seen in Cisco iOS. So the full form of IP SLA is Service Level Agreement. You might be already aware of IP SLA, where we use this especially for ISP redundancy. Okay, but it can do lot more than the simple ISP redundancy failover. So there are a couple of things SLA or IP SLA can be used with. Okay, so for example, I have a router. Let's say consider I have two routers. If let's say we have the host machine, so I can set some ping between them, right? I can have my host pinging to R1 and similar way host pinging to R2. So one such factor for IPSLA is a simple ICMP. If I say that if I get a drops for continuous to 3 milliseconds, then don't send the next traffic to this, instead send the traffic to R2. Similar way, I can also make sure my voice packet UDP, or I can make sure that due to any delay or due to jitters or due to any depending upon the services or depending upon the quality, I can say that if something happens, then fail over or switch over to the next link. So we can set multiple parameters. So along with these parameters, we can also set something called as tracking. Let's say if I enable a tracking over here, I say if this goes down, then that should be a criteria for the link to fail over to a new link. So totally all this together with the features, with the tracking, we specially use this for dual ISP redundancy case. So you might be aware that a lot of times when we have uh, router 1 and router 2 in our enterprise, and let's say if this connects to one of ISP, internet service provider, and we have another internet service provider. So you might have heard we saying that we are making use of IPSLA, right, to monitor the quality of one of the ISP, and if we are not happy with that, the link will auto fail towards the next link. So the next active connection happens with respective to ISP2. That's because we are gonna set multiple features, like we can set it UDP connection, DNS, DHCP, STTP, TCP connection, and based on the quality we can set that if so and so things happen, if so and so times the packet fail, then just switch over to the new link. So this features along with the routing switching we use in for redundancy basis. Okay, so let's see from theoretical point of view what exactly IPSLA suggests. So you can see it's a service level agreement. We are gonna set services and we gonna uh, put a level to each services, that if we see so and so thing happening, then prefer the second link. Okay. So it's basically a measure of network performance. If something is bad, you just have your features enabled and it will pick the second link. Okay. Ping is one factor. Very simple option would be ping, which works on echo request and echo reply. So I can set if there is a timeout, if there is a frequency, and if something is not good, then I can say that my first source is not well and not reliable. So let's move on to the second link. Okay. With along with ping, we can also make sure the voice traffic, the UDP traffic, can also be manipulated in a similar way. If ISP1 is not good, we can set that if delay or jitter or any quality, if it doesn't matches my requirement, just switch the link to the second one. So basically what happens is when we assign our service levels, when we assign that I need so and so delay and so jitter, there will be something called as MOS getting calculated. Okay, it's called as mean opinion score. So this is a score which happens out of 5. Let's say if I set some parameter and my MOS score was like 4 out of 5. Okay, that means that's a good thing. Now immediately if this goes bad, okay, if this goes bad, then then what happens is the first link will be switched over to the second link. Okay, so I'll show you this. How does the score look like? Uh, as I told you, it's about network performance. So basically, you can also enable IP SLA with other routing protocol like OSPF, EIGRP. That's why we see uh, IP SLA most probably used in dual ISP scenarios. When one of the ISPs is not performing well, we still have a reason to move towards the second link. Okay, and important thing is how do we set this? We can set this 24 bar into 7. We can set 9 to 5. So it's a operations that we are gonna do. We gonna set it. Okay, we gonna set on which what is the type of traffic, what is the source, what is the destination, what is the port number, and then we are gonna run the operation. Do you need it for a day? Do you need it for a lifetime? Okay, we have all these options in IP SLA, and this is regards to the normal ping, which is RTB, return traffic. So basically, over here we can set something called as RTP, which is nothing but round trip time. So that's the time from source to destination and back from destination to source. So the whole RTP time can be calculated. Let's say if it is 10 milliseconds, and I can set it as a factor. If I receive my packet more than 10 millisecond, that means there is some delay happening here. Might be if it takes 20 millisecond, right? So that means there is some delay somewhere, right? So I can set my IP SLA in such a way that if it crosses 10 millisecond, then don't prefer that link. Might be go with the second link or whatever second connection that I have in my network. So what about IP SLA, with which different operations can we use? We can make use of it with respective to TCP connection, UDP connection, DNS, DHCP, HTTP, FTP. So these are all different operations or different type of services based on what we can have our IP SLA configured. So we have two basic GNS lab. One is to see the ping operations, which is ICMP Echo operation, and the second one is UDP. Okay, so we can do a lab on these two things, and we can see how does it work. And yes, I also have a assignment for you guys where you will set the where you will set two ISPs. Okay, let's say by default the traffic takes ISP1, and you set some parameter, and you will shut down the interface so that IP SLA tracks that interface is going down, and then it start forwarding those traffic towards ISP2. Okay, so this is something which I will give you guys to do. It's simple configuration. So we will do the first one, that's with respective to ping. Okay, so just take any two routers which you have on your lab. So let's say I go with this one, AT&T 26 and Vodafone 27. So let me show you how does IP SLA works based on the normal ping or echo packets. So let's say this is my first router. So I go to the router, go to configuration T. I have to enable IP SLA, the session ID. Okay, so I'll start with the entry number, and then what features do you need to enable this for? So you can have with DHCP, DNS, Ethernet, right? There are a lot of options. So let's go with ICMP Echo. Okay, for the ping response, ICMP Echo. We need to give the destination. What is the destination? So in my case, this is the destination, the opposite router. Now let's set some frequency. We need to set a frequency. What is your ICMP echo, or how frequently you wanna send your ICMP echo. So you can change these values depending upon your production environment. So let's keep it as 10. Okay. So once you have this, we will set the IP SLA to work between 9 to 5 or 24 into bar 7 or forever. Okay, so the best option would be setting it forever. If you want to have it monitoring or allowed to uh, work just for 9 to 5, you can set that, or the way you want it. Okay, so let's say I have IP SLA and I want to schedule it for give some. So there are a couple of things. There's like age out, life, recurring, start time. So let's go with start time. Okay, and I say that start now, and I can go with like life forever if in case I want to keep this on my router. So that's all. That's the command for enabling IP SLA based on ICMP. And how do we monitor this? We have commands like show IP SLA configurations. So if you see this, let's talk about the schedule which we have done. We have the thresholds. These are all the numbers. There's one more command called as show IP SLA statistic. So over here you have your latest RTT, which is 3 millisecond. Okay, so we can set this timer. If I get anything above that, then this is a service disruption, go with the second link. So a lot of things we can do. This was just enabling of ICMP. We can enable this ICMP along with the routing protocol. That's a good thing about IP SLA features. So these are number of successes, number of failures, time to live. Okay, so this is how we enable the normal ICMP echo. Now similar thing, let's enable it for a UDP packet based on some jitter or based on some delay. Let's say if uh, echo or a ICMP echo is not the main criteria for the switchover. Instead, I want even the slowness to be one of the main factor to make the link or to make the decision from link 1 to link 2. Okay, so in that case we can enable another set of IP SLA. We can come up with let's say IP SLA 2. I can talk about like UDP Jitter. Okay, jitter is some components which is being added up, or it's something which cause issues or cause slowness in the traffic movement. Okay, so let's say we have set some UDP jitter. I set the destination IP. We will give some port number which is required for UDP jitter monitoring. So let's say we have anything greater than 1024. Since it's a UDP traffic which deals with video traffic, so we will give the codec, and we can give any of its encapsulations. Okay, so we can give the first one itself just for testing purpose. Okay, you can set some frequency. What is the frequency, or how often you wanna monitor this for. Okay, you can also set something called as type of service. Okay, if you do a normal question mark, you can see there are a couple of things: timeout, precision, owner, optimize, frequency, TOS, type of service, where you can set your different service values. Okay, so just an example. And once you have this, you will set your IP SLA, or you will enable your IP SLA if you need it 9 to 5 or 24/7. So the command would be IP SLA schedule to life forever, start time and now. So this is how we enable IP SLAs time to time, or service to service. Okay, the commands are same. It's IP SLA configuration and whatever IP SLA session that you created or entry number you created. So this is in the case of the second session, so which was with respective to UDP jitters. Okay, and this is the statistic of that. So this is with respective to enabling IP SLA. Okay, now you guys will have the assignment where you will configure two ISPs, ISP1 and ISP2, and then you will integrate whatever we did the configuration for IP SLA along with routing protocol. So IP SLAs can be integrated with routing protocol as well. We can integrate it with RIP or EIGRP or OSPF. So that's how we use IP SLA for the ISP tracking and switching over. Okay, so the requirement is, so let's say this is a user and this is internet. So we can use any routing protocol. We can use the simplest one, EIGRP itself. So by default, let's say the traffic was over here. Okay, so we can set some IP SLA. We can set some IP SLA, and we can set it on basis of ICMP tracking. So if the link is down, the we see the next packet is going across ISP2. Okay, so the configuration is over here. These are ISP1 configuration. Okay, interface configurations and the EIGRP configuration. Similar way, you have ISP2 configurations, which is over here. Okay, so you have your interface configuration and the EIGRP configuration. So similar thing you have to do it over here. You will have your interface configurations, and there's a loopback. You can create a loopback for 8.8.8, and then you can advertise on EIGRP. So what happens is they will share their neighbors. The database gets synchronized, and you can see you can see the trace route from your first machine or the host machine towards 8.8.8. Okay, so the one with the best path will be taken up as a primary path, and then you can enable IP SLAs so that you can test and you can prove if this works or not. So basically what you need to do is you need to create your IP SLAs. You will mention your echo on 1.1. You will set some frequency. You will set your timeout requirement. Okay, and you will enable this forever. And you can also configure tracking, or you can bind it with the IP SLA that you are running now, IP SLA 1. Okay, so you can start your tracking code 10, where you're tracking IP SLA 1 reachability, and then you can set the tracking numbers, tracking 10 and tracking 20. So tracking 10 is for ISP 1 and this is for ISP 2. Okay, and just to prove that, you can shut down one of the link so that the traffic will move automatically over on ISP 2. Okay, so this is the features that we use when we have two or the dual ISPs with us, and these are all the show running configurations. Okay, you see this is when it's reachable. Okay, the status code is okay. So as soon as you shut down the interface, the tracking is gonna detect that interface was made down. Okay, and once after that, once you shut down your ISP 1. Okay, once you shut down your ISP 1, you will see your IP SLA has detected that it has made it down, and it will automatically shift towards ISP 2, and you will see that in your routing table. So you will see your trace route or the fresh trace route, which will take up the second ISP now, ISP 2. Okay, so this is IP SLA. I'll also go with the second topic, which is again the simplest topic. Okay, and it's called as Cisco NetFlow. Cisco NetFlow. Okay, um, so you might be aware of how SNMP polling happens. You might also be aware of the other things that we had discussed, like span, ER span, and R span. Okay, so Cisco NetFlow is a Cisco proprietary once again. Okay, and how is it different from SNMP is when we have a lot of similar traffic in case of SNMP, or let's say we when we have similar traffic like source destination uh, is all the same, the SNMP will not be able to differentiate the traffic here. Okay, whereas the Cisco NetFlow is one such feature which will be helping us to differentiate the traffic. Okay, so you can take it in this way that those traffic where SNMP is not capable of differentiating, Cisco NetFlow is going to help. Okay, uh, so basically how it works and what kind of traffic that it's gonna differentiate, we will see it. Okay, so basically NetFlow, as name suggests, it is for collecting IP traffic information. It collect IP uh, traffic information. It's a Cisco proprietary. So it's a unidirectional traffic that's source to destination. Which kind of traffic will Cisco NetFlow able to differentiate? It will able to differentiate those traffic which share the same characteristic. Okay, which is going to share the same characteristic. That's very important word here. When you have a different characteristic of traffic, then the SNMP or syslog can detect it. Okay, but when it's same, then you need NetFlow. What else here? So basically characteristic like the same source, it can be same destination, it can be same port number, it can be same protocol, or it can be same type. So these are some characteristic which when I say same, okay, when I use the word same, it's something can be source, same, similar destination, similar port number, similar protocol, or similar type. It can also track the number. Okay, it can also track the number of byte sent or packet sent or byte sent or packet sizes, and so on. Okay, so basically we will configure the router to keep the track of all the flow and then export them to central server. So how the NetFlow works is we need to configure first on the router, and then from the router we take it to some server. And Cisco has their own product which is called as Cisco Collector. In short form, we also call as CSPC, Cisco Collection, Cisco Profile Collection. So basically, this is used in enterprises. So this is one of their product which is used uh, to collect the device or the traffic. So basically, this comes in both on-premises and cloud solution. So we can deploy this in the customer end. So they directly integrate with the customer devices. So the customer has to allow the required firewall rules. They have to allow the required port numbers. The frequent polling will happening. This is the collector profile which will, using the NetFlow traffic, will get all the device information, syslogs, and all remaining things, and then send it to the next agent. The next agent could be the SNMP agent, or it could be any other Cisco tools, okay, where the engineers can get all the syslog from the devices. So basically, engineers will not have the access to the real boxes on the customer side. So they have this kind of deployment, and from this deployment they get all the required information. So what else does this NetFlow help us? So it's basically will show us the real data, like who is consuming the most bandwidth. So basically, NetFlow will also show us the top talkers. Okay, we can see the top talkers. If you do not know what is top talker, then on iOS we can see which is consuming the highest bandwidth, which service is taking a lot of CPU utilization and lot of other things. So we can enable it on two ways. We can have those Cisco collectors which can show us in graphical, or we can enable directly on the Cisco CLI to see the top talkers. Okay, so these all works, or this all happens if we have the NetFlow running. So basically, this protocol will give the insight to the network traffic. It will keep the track of all the flow, and then help it export to the central server. We can collect the data flow from routers, switches, interfaces. Okay, the provide stats on packet flowing. So basically, all regards to packet flow, the ingress traffic, egress traffic, or both. Okay, so it's a UDP port. Okay, so basically we need UDP port number 2055. Otherwise, we can also see some enterprise making use of UDP port number 9555 and 995 for NetFlow to get enabled or get or get integrated with those devices. Okay, so it is used for accounting, security, auditing. Okay, NetFlow is going to consume additional memory because it's going to, after all, captures those traffic and send it to external servers. Okay, so that was a short brief about NetFlow. It comes in multiple variant. We are only interested in version 5 and version 9. Okay, so basically, if you see, the version first is obsolete from the market, and it was only for IPv4. Later on, Cisco launched couple of versions like 2, 3, 4, but they were never released. Okay, they were just unofficial announcement. Then there was something called as version 6, which is not compatible with Cisco routers. So it's version 5 which is used in IPv4, which also supports BGP. It is exporting data from main cache. Uh, no real concept of ingress and egress flow. NetFlow added flow sequence number, so basically it added some sequence number additional field. So basically it did some uh, improvised on its format, okay, on its working. Later on in version 9 there was lot of in improvements, like the NetFlow version 6 can be integrated with IPv6 also. It can support MPLS traffic as well. Okay, so the export data from main and aggregation cache. So there are some improvised things which was introduced in version 9. Okay, so widely used versions are version 5 and version 9. So what does it do? It's for segmenting the traffic. Okay, so basically if this is the traffic, you can segment the traffic. You can say what's the bandwidth of the traffic, like say for example, if you see here in terms of color, you can segregate the traffic in 3 different color. You can see what is the bandwidth percentage utilized of each one of them, and on what kind of traffic that we are discussing about. Because if it was a normal traffic, then SNMP can do the job, but we are talking about that traffic which is having the similar characteristic, okay, which SNMP will not be able to help us, like on same source IP, same destination, same port, source port, destination port, layer 3 protocol, class of service, input interface. So these are some characteristic which based on which we can use NetFlow to segregate the traffic, 3 different traffic based on very similar options. So that's where we need NetFlow. And NetFlow is a protocol. On the other side, we can make use of Cisco Collector. It's a on-premise devices, or we can also deploy it on hypervisor or the virtual machines or VMs, and we can have the dashboard setup. So the dashboard something look like uh, this. So this is the dashboard of Cisco Collector, and so you can see here there are a lot of devices being polled. Okay, you can see the device health, device uh, reports. It's gonna send the device reports time to time. What are the logs? What are the device statistic? Okay, yeah. So these are the few field to identify unique flow. So flow which SLMP is not able to recognize, you can easily get it done over NetFlow. Okay. Easy lab, nothing much here. So I'll give this as assignment. So you basically can consider these 3 devices to try this NetFlow. So I'll explain you what has to be done. So you have your interface configurations on R1. You have your interface configurations on R2. Okay. And then we will set some NetFlow configurations. So the green highlighted ones are the configurations, and the yellow highlighted ones are all the show commands that you need to see uh, if the NetFlow is up and running fine. Okay. So over on the interface level, you have to enable the ingress. So basically this is your source where you are going to capture your incoming traffic. Okay. And then let's assume this is that collector, the destination. Okay. So you're gonna set your destination and the IP address. You're gonna export it. So you're gonna say that this is your incoming interface. You're gonna say which version of NetFlow are you using. So since you're making use of version 5 uh, as your first lab, so you will set it as version 5. What is your time out active value? What is your timeout inactive value? So just few commands and you have your NetFlow enabled. You can make use of show commands to see the different counters there. What is the packet capture? What are the exported traffic? And similar way, the version 9. Okay, so you know that version 9 supports IPv6, it supports MPLS, it supports the export and uh, the import. Okay, so basically few other or few add-on things we see in v9. So the configuration, once again, it's interface basis, so you have to set your source on your source interface, which is your ingress traffic. You have your destination set, which is acting as your collector. So you will set your source interface, you have your version 9, you have your active and inactive, and then the show commands. Okay, so that's a small lab. There is nothing much there. So that's something which I'll give you guys to get it going. So basically, this is your traffic hitting on this box, and that the box is now going to send that traffic to the collector. Okay, this is your Cisco collector. And yes, so those guys who don't have the smart collector, as I told you, you have two ways to see the top talkers, either on the GUI, the graphical interface, or the GUI interface of the collector, or on the CLI itself. If you want to see it directly on the CLI, then you have to enable 4 more commands. You have to enable the flow talkers, top 10. If you want to sort it by packet and bytes, then just enable it, and the single command to see the top talkers. Okay, so this is how the NetFlow is enabled, configured, and seen directly on the CLI. In case if you don't have collector, if you have collector, then you don't have to do this last few commands. Just enable the protocol, start sending the packet to the collector, and collector will give it in a spread out or in a spreadsheet or in a graphical interface. Okay, so that's all about the two topics. One is IP SLA and the second one is NetFlow. Both are the topic under NCORE as well as NRC under network assurance heading. Okay, so you will see this topic IP SLA and NetFlow both in NCORE and NRC, both, not just one. It's a topic which is something which we see in both of the module. It's a simple topic because the whole main topic itself is 10 to 15%. So in that 10 to 15%, you have a lot of things fixed or fit inside those 10-15%. So there's not much here, but yes, you should know the things what's uh, mentioned in the blueprint. Okay, so let me know if you have any doubt, and we are good with winding up the class. Okay, how to enable SLA in Cisco ASA? So basically, you have to enable IP SLA the same way you enable it on Cisco router. It's the same thing. You have to enable the tracking, and you have to enable the IP SLA feature. So it's over here. This is on router, but the same commands will work on Cisco ASA as well. Yeah, netconf and restconf is the topic in network assurance, which I'll cover in the next class. Okay. What topics are left in the course? We are left with IPv6, QoS, wireless, and automation. So, and yeah, we have a few here and there topics, small topics, but these are some major topics. Okay. So, wireless and automation, we will start very next after we have done with assurance. Okay. We'll start with wireless and automation, and then might be we are left with IPv6, QoS, and few some some small topic here and there from the corner. Okay. And yes, from a certification point of view, you can expect one question from IP SLA. It can be related to the tracking, what is the right command for IP SLA enabling, or that kind of topic. Okay, so not much here. Might be one topic, one question, because you have other topic also under network assurance like network, netconf, restconf. So there are some topics, questions coming from netconf and restconf also. So just one question you will get from IPSLA, not more than that. So guys, let me know if you have any doubts. All right, guys. So I take it as no from you all, and if you have any doubt, you can post it over on the group as well. We are all there in the group. While doing lab, if you get any doubt, you are free to post it on the group itself. Okay. Fine, then I'll pass on the recording with the PDF. So start doing, start practicing your lab. Okay. And yeah, one more thing regarding the CCI lab, it's coming up. So from September, you can see your Cisco labs for CCI. I'm talking about CCI. So the labs are coming up from September. The Cisco is releasing it in China, and might be after a few months you can see the labs getting started up in India or other part of the world as well. Okay, so keep preparing in case you have not yet written your NCore. Then start practicing for NCore first, and then you can start practicing uh, for the lab itself. Okay. Uh, I meant to say that it started up in China, but it will start up in all other part of the world as well very soon. Okay, so that's a great move or great news from Cisco, uh, which we were all looking forward. All right, guys. So we'll meet up in the next class. Stay safe till then. See you soon. Okay.